So picking up where we left off yesterday, looking at power and radical functions. So example 3, rational exponents. So what's a rational exponent? Fraction. So like when we have a rational function, where we have our x's in the denominator, it's a fraction. So a rational exponent is x to a fraction power. So we're going to describe the domain, range, intercepts, end behavior, continuity, and where the function is increasing or decreasing. So let's graph this so that we can look at the function. So xing out and going to Desmos. All right, so looking at this graph, what do we notice? What observations do you have for this graph? Okay, so our domain, so if we look at our x functions, so looking at our x-axis, we're going from 0 to positive infinity, so our domain is 0 to positive infinity. What about our range? Same. So for our range, we're starting at 0 and then going up our y-axis to positive infinity. We're only in the first quadrant. Yeah. Intercepts. What x, y intercepts? 0, 0. We're only crossing the y-axis and the x-axis at the origin. End behavior as our x. How many end behaviors do we have? We have 1. We're going off to the right. So our end behavior as we go to the right, what's happening to our, as x approaches positive infinity, what's our function doing? It's going to positive infinity. Continuity. The function, it has a definite starting point, correct? All right, so it's starting where? At 0, 0. So if we're looking at continuity, our smallest x value is going to be 0. Do we have any breaks? Do we have any discontinuity as we head right? No. So our function is going to be continuous starting at 0 and going to positive infinity. Increasing, decreasing?
It's increasing from 0 to positive.
Perfect. It's increasing from 0 to positive infinity. So question, we verbalize everything. Do you want me to write all that stuff down?
No, but I have a question.
Yes.
If it is the start, like over here on positive infinity, and then it goes down, and then it crosses the origin, and then it goes back down, would you want us, for the increasing to decreasing? Do x to the third. There you go. Yeah.
Okay.
Yeah. What for our increasing to decreasing? What would that be? Would that just be
all right?
Positive and negative?
So going from left to right, we're starting down here, and we're going up. So is it decreasing ever?
No.
No. So it's just increasing from negative infinity to positive infinity.
And then if it was flipped, and if it was like a negative, is that what that? No.
You want the reflection of it?
Yeah. Yeah. Then it would just be negative infinity.
Right, and that would be
Positive infinity, negative.
Well, we from left to right. So from left to right, we follow it. Are we increasing or decreasing? Decreasing from negative infinity to positive infinity. Yep. All right, so looking at this one isn't on your notes, but what's the difference between this one and the one we just looked at? All right, so here we have a negative exponent, and so we're gonna. It is. So we have 4x to the negative 2/5. I'm writing it down. So let's go into Desmos. All right, so looking at this graph. All right, so let me get it. There we go. All right, so here, now when we have a negative exponent, what does that do? If I have x to the negative 2, how do we rewrite that?
Reciprocal it.
Right. And so here we have a negative exponent, so we reciprocal it as well. So this is the same as
How do you reciprocal fraction exponential?
It's the same way. You drop it to the denominator. So this is the same as 4 over x to the 2/5. And so this is what the function looks like. So looking at this, is it continuous? First off. No, we got this big old hole going on here, and it was really zoomed out initially. So if
Is that going to a certain point coming back, or is that just continuing?
well, what if we look at the bottom? Can it be 0 in the denominator? No. So we can't plug 0 in for x, because 0 to the 2/5 power is still 0, right? So here, our x value is never going to be what? 0. So with that, we have discontinuity there. And what type of discontinuity do we have at 0? Not jump. We have infinite. We have infinite. We have both sides, both from the left and to the right, are approaching what value? Positive infinity. So we have infinite discontinuity at 0, where both sides from the left and from the right, as we approach 0, we're approaching positive infinity. What about our domain? What would our domain look like? What are all the x values that we can be? All right, so and then what number can it not be? 0. And then we skip over 0, and we can do all of the decimals all the way to positive infinity. What about the range?
From 0 to positive.
Right, so we're starting at 0 and we're going to positive infinity. And then if, since this is x to the 2/5, right? So what does 2/5 telling us? And we're going to get into this later in this section. But how can we write that as a radical? Okay, we'll get into that. There's a reason why it's not in the negatives, but we'll look at that. We'll hang on to that. So here we're going from 0, and then we're going to positive infinity. We're going up, so we're increasing. We talked about continuity. What about our end behaviors? As we head out to positive infinity, what's our end doing? What's it approaching?
0.
It's approaching 0. And then as we approach negative infinity, we're approaching 0 as well. Questions on that? All right, so looking at power regression, let me bring it up on here. I think you guys have a different one, probably. All right, let's do the one that's on your notes. Oh, never mind, it doesn't have anything. All right, so we'll use the data that's on the table. Actually, I think I need to go back a slide. All right, well, we'll just do this data here. So let's write this data down. So we have we're gonna do it on Desmos. So let's copy that down, and we're gonna put it into Desmos. Yeah. So you're gonna insert a table. All right. So we're gonna insert a table, and then we're just gonna put all that data in. 2, 3, 6, 7, 9, and 10. Alright, then we're going to adjust our screen so that we can see everything. So we have something that looks like that. Okay, so it asks us to create the scatter plot, determine a power function to model the data. So in Desmos, what we're going to do is from data, we're creating an equation. So this is a regression, kind of working backwards. So what we're going to do is we're going to go to our second line here, and we are going to plug in our function. So I'm going to start with in our table, our y value is y sub 1. So we're going to put y sub 1, or y1. And then to tell the program that we're doing a regression, we're going to do the tilde, NA, accent thing.
Did you just, when you said y sub 1, did you just put one?
I just want, yeah, y and the number 1. And then our power function, it was a x to the power, correct? So we're going to do a x, and then we're going to do a x to the p power. Uh-oh. Oh, what I forgot. On my x, my table, it's x1. So I need that to link it to my table up here. And so now I have, it's giving me the, you can change it in the table, yeah. So here we have, so now it's creating it's showing a power function for us. This a value in our table here, that's the a value, that's our coefficient in front of our x, and the p value is our power, is what p equals. So the equation that best represents our data is 4.3592 x to the power of 2.9861.